Hello everyone, how are you? I hope you are doing well and welcome back to this session where we'll be talking about a new topic, and that is called your population regression function. So we have already talked about regression and we've talked about the simple regression function. Okay, we've talked about the assumptions that we follow while creating our model and regressing the dependence of a dependent variable on the independent variable. So let's create a function and try to regress the dependence of y upon x. Okay, so at the first place, we'll be talking about the population and then we'll talk about the sample. So we'll see what difference is there in the population regression function and the sample regression function, and we'll also learn that it is more feasible for us to have a sample regression function rather than the population regression function. So through the sample regression function, we try to predict the population like through the parameters that we fetch out of the sample regression function. We in a way try to predict the population parameters. So the parameters basically your beta 1 and beta naught and beta 1. Okay, or in some cases beta 1 or beta 2, like depending upon the notation that you use. So let's have a recap and let's talk about what regression is. Okay, so regression is basically, or the regression analysis is basically concerned with estimating the the mean value of the dependent variable on the basis of some known or fixed values of the explanatory variable. So predicting the, sorry, the mean value or expected value, expected value of the dependent variable, I'll call it y, okay, of the y given the value of, or given a set of values of your dependent variable, that is your x. Okay, so we'll try to understand this through an example what this line actually means. Okay, so we'll take the example of, or we'll take the case of your dependence of weekly income and your weekly consumption. So we'll check the dependence of your weekly consumption upon your weekly income. So we have a set of data. Okay, so this data represents the entire population. So supposingly we have a data set that is of the entire population, and through that data we'll try to formulate the population regression function. Okay, so the data looks like this. So I'll have to use a different page for that. So we have here weekly family income. This is your x variable, and we have, okay, so I have to draw better lines, I think. So this is your, okay, this is x variable. So in here we have, so this is your weekly family income. This is your weekly consumption expenditure. So this is your y variable. Okay, so this value of x is fixed. So we have a fixed already defined values of x. So we have taken some values of x, say suppose $80, $100, $120, $140, and $160. So we have already preconceived the values of x. So for these x, we'll try to find the values of y. So we have decided to look for families with consumption with income equal to $80 in a week, and $100 in a week, and $120 in a week, and 140 and $160 in a week. So based on these values x, we'll calculate the consumption corresponding to these each x value. So for uh, we'll do a survey in the population. So in this case, we are taking the entire population. So whatever families are there who have family income, a weekly family income of $80, we'll check what is their weekly consumption and we'll record that data. So suppose the data goes like this. So we have a family which has a consumption expenditure of weekly consumption expenditure of $55. Then there's a family with 60, then we have 65, then we have 70, and then we have 75. Similarly, when we go looking for families with weekly family income of $100, the consumption expenditure weekly varies like this. So there's a family with $65 consumption, $70 consumption, $74 consumption, $80 consumption, 85, and 88. Okay. Similarly, I have different values for each different level of weekly family income. Okay. So in here we have 79, 84, say 90, 94, and 98. In here we have 80. This is 80, 93, 95, 103, 108, 113, and 115. So these numbers, like for the case of $80 as weekly family income, I have the data of five families. So there are five families with $80 weekly family income. Okay. Similarly, I have a different number of data set for families who have $100 of weekly family income. Okay. So depending upon the kind of population I'm dealing with, so these number will vary. Okay, depending upon the number of families I found corresponding to a given value of x. Okay, it doesn't have to be similar. There might be different families with different family incomes. Okay, this is 107, 1110. Then I have 116, and then I have 118, and then I have 125. Okay, so what is my aim here? So I have to find the expected value of y given xi. So what is my xi? This is, say, x1, this is x2, this is x3, this is x4, and this is my x5. So given each xi, or given x1, x2, x3, x4, x5, what is the expected value of my weekly family consumption expenditure? Okay, so if supposingly there are five families with weekly family income of $80, what is their average weekly consumption expenditure? That is what I have to calculate. Okay, so for every x1, I have an expected y value. Okay, for for x2, I have an expected y value. For x3, I have an expected y value. Okay, so this is how it goes. So that is what I'm trying to compute here. So if I plot this on a graph, this will make things more clear. So I have 80, I have 100, I have 120, I have 140, and then I have 160. So these are my x values, or my x variable here. Then I plot here y variable here. So corresponding to $80 of weekly family income, what is the average weekly family expenditure? So if I go back and take the average of these numbers, okay, that average will be represented by a line here. Okay, so if I calculate the average will come out to be 65 for this one, 77 for this one, 440, sorry, 89 for this value, 101 for this, and 113 for this. So corresponding to $80 of weekly family income, the average weekly family consumption is $65. Similarly, for $100 of I have $75 of weekly consumption. Okay, average weekly consumption, and this is how this line goes. Okay, so this is your population regression curve here. So it is basically the locus, or uh, the geometric representation, or the geometric representation of how the average value of y, or your weekly family consumption, is changing if I change the value of weekly family income. Okay, so corresponding to different weekly family incomes, I have different average weekly family consumption expenditure. This is what is being regressed by this population regression function. So your population regression curve is simply the locus of the conditional mean. So when I say E, y given x I, okay, so this becomes your conditional mean, because your expected value of y is depending upon your xi value, which in this case varies from 80 to 160. Okay, so your population regression curve is simply the locus of the conditional means of the dependent variable y for the fixed values of explanatory variable. So in every case, like whenever we have to regress something, my x values will be fixed beforehand. So I'll fix my x values, and then I go for a survey, and I'll find corresponding y values from my survey or whatever data that is available for me. Okay, so this is how your regression works. So from this explanation, it is very clear now that your expected value of y given xi is a function of your xi. So because if the values of xi are changing, then the expected value of your weekly family consumption is also changing. So your expected value of y is basically a function of your xi, okay, or your dependent or your independent variable, right? So this is a condition that we know now, but we don't know this functional form. What sort of function is this? So is it might be sine of xi, or cos of xi, or e to the power xi. So it is some functional form, but I'm not aware of the kind of functional form this dependence has. This dependence. Okay. So how do we calculate this, or how do we get to know that what this functional relationship is? So basically we assume. So economics is a lot about assumptions. Okay, so we assume that the functional form may be of the form that you expected y given xi is some constant beta naught plus beta 1 xi. So this might be the sort of relationship that might be followed between expected value of y given xi and your xi, the independent and the dependent variable. Okay, so since we are dealing with simple linear regression, so it basically means, so this linear basically means that my relationship, this functional relationship, is basically linear in parameters. Okay, parameters. So in here beta 1 and beta naught, these are my parameters. Okay, parameters. So they are linear, as in the power of beta naught and beta 1 is 1 only. So whenever this is not the case, that becomes the case of your non-linear parameters. Okay, and in this case your variable is also linear. Okay, So in simple linear regression, our parameters must be linear. Okay, your variable might vary with a different sort of functional form. Okay, they might not be linear, but for simple linear regression, your parameters must be linear. Okay, and in this relation, we know that beta naught and beta 1 are your unknown unknown parameters. Okay, so in the case of population regression function, from if I have this data available with me, I can easily calculate beta naught and beta 1 by plotting this graph. Okay, from this I can easily get this get the values of beta naught and beta 1. But we, in practical terms, like in real life, we don't have we don't have the population data. Like it's very hard to collect data for the entire population, but we have to estimate this uh, dependence or this relationship, right? So because this is what something that interests us. Okay, we want to know how something is related in the population, how some variables are linked, how variable might change if certain factors or certain variables are changing in the population. So our area of interest is the entire population, but our limitation is that we can't find the data for entire population. Like it's very tedious, it's very costly, it's very time consuming. Okay, you like if I give the example like of India itself. So if somebody wants to calculate the dependence of monthly consumption expenditure and monthly family income for the entire population of India, which is around say 150 crores. Okay, so collecting the data for the entire population of 150 crores is like impossible. Okay, impossible. So even in national surveys, it's like really impossible to collect the data of the entire country. Okay, so that is why sampling becomes important. Okay, so in sampling, what happens is, suppose this is the population. Okay, this is the entire population. So since we can't acquire the data for the entire population, we take small samples. Okay, so we'll take sample data, and through these samples, we'll try to estimate your population parameters. Okay, so this is how it works. So okay, so we know the relationship now. Like it's a sort of assumption only, but we know that we'll be dealing with the expected value of y given x1 is related to x1 in this form, right? So what this means is, if x is here or xi is here, so there is a value of y, an average value of y that is lying on the regression curve, or this curve is basically the locus of these expected values that are corresponding to different x values. Okay, so this is your e of y given xi. So there might be different values of y given the same xi, but this is the main center of attraction because it is the expected or the average value of all the values that y might take or y will take when x is equal to xi. So if suppose this is your y, okay, so I can write y is equal to uh, ex- expected value of y given xi plus UI. And what is UI? So UI is basically this gap. So this Y value is basically this expected value plus some error term. Okay. Or I can write that your UI is basically your Y minus E of Y given Xi. So this is basically I. So ith Y value is basically the summation of your expected value plus an error term, which is the difference between your actual value and the expected value. So this is also how you can write your error term. So this is your population regression function. I hope it made some sense. So it's basically an estimation of the population parameters. Okay, and we try to find how your y variable is changing when we are changing the values of your x variable, right? So this dependence is being captured. So this is for the entire population. In the next video, we'll talk about how we create a sample and how from a sample we'll try to estimate the population parameters. Okay. So I'll see you in the next video. Till then, thank you.